The Sun, a giant ball of hot gas, a celestial furnace that has blazed for billions of years. It is the anchor of our solar system, the source of energy that sustains life on Earth. The Sun's gravitational pull keeps our planet in orbit. Its light and warmth make our world habitable. Without the Sun, there would be no Earth as we know it. From our perspective on Earth, the Sun appears as a bright yellow disk in the sky. But the Sun is much more than just a source of light. It is a dynamic and complex object, a star that undergoes constant change and upheaval. Its surface is a swirling mass of plasma. Eruptions of energy burst forth, sending streams of charged particles into space. The Sun's influence extends far beyond our planet. Its gravitational pull affects the orbits of all the planets in our solar system. Its solar wind, a stream of charged particles, flows outward, shaping the space environment. The Sun is a powerful force in our cosmic neighborhood. Its presence is felt throughout the solar system. The Sun's energy comes from nuclear fusion. Fusion is the process of combining atomic nuclei to create a new element. In the Sun's core, hydrogen atoms fuse to form helium. This process releases an enormous amount of energy. This energy is what powers the Sun. Fusion occurs under immense pressure and temperature. The Sun's core is a scorching 15 million degrees Celsius. It's hot enough to strip atoms of their electrons, creating a sea of charged particles called plasma. The high pressure forces hydrogen nuclei close enough to fuse. The energy released from fusion takes many forms. It includes light, heat, and other forms of electromagnetic radiation. These forms of energy radiate outward from the Sun's core. They eventually reach the surface and escape into space. This energy powers our world and illuminates the solar system. The journey of light from the Sun's core to its surface is a long and arduous one. Photons, the particles that carry light, are constantly being absorbed and re-emitted by the dense plasma. This process can take hundreds of thousands of years. Photons bounce around, gradually working their way outward. As photons travel outward, they lose energy. The Sun's core is hotter than its outer layers. This means photons gradually shift to lower energy levels. This shift affects the wavelength of the light they carry. When they finally reach the surface, the photons emerge as visible light. The Sun's surface, called the photosphere, is a turbulent layer. It churns with convection currents. These currents transport heat from the Sun's interior to its surface. This constant motion gives the photosphere a granulated appearance. It also contributes to the Sun's dynamic nature. Once sunlight escapes the Sun's surface, it begins its journey through space. Space is a near-perfect vacuum. There's nothing to impede the progress of light. It travels at the fastest speed possible, approximately 299,792 kilometers per second. It is a universal constant that governs the cosmos. Sunlight travels in straight lines. It spreads out as it moves away from the Sun. This spread reduces the intensity of the light. The further away from the Sun, the less intense the sunlight becomes. Despite this, the Sun's light reaches far beyond our planet. It illuminates the entire solar system. The Earth is approximately 150 million kilometers from the Sun. It takes sunlight about 8 minutes to travel this distance. This means we see the Sun as it was 8 minutes ago. When we look at the Sun, we are looking into the past. We are witnessing a moment in time that has already occurred. When sunlight reaches Earth, it encounters our atmosphere. The atmosphere is a layer of gases surrounding our planet. It acts as a shield, protecting us from harmful radiation. It also filters and spreads sunlight, shaping the light we see. Our atmosphere absorbs some wavelengths of sunlight. For example, it absorbs most ultraviolet radiation, which is harmful to life. This absorption process helps regulate Earth's temperature. It prevents the planet from becoming too hot. The atmosphere also scatters sunlight. This scattering process is why the sky appears blue. Blue light has a shorter wavelength than other colors. It is scattered more effectively by the atmosphere. This scattered blue light illuminates the sky. Sunlight is essential for life on Earth. It provides the energy that drives photosynthesis. Photosynthesis is the process by which plants convert light energy into chemical energy. This process produces oxygen, which is essential for animal life. Sunlight also influences Earth's climate and weather patterns. It warms the planet's surface, which drives atmospheric circulation. This circulation creates weather patterns, including wind, rain, and storms. Without sunlight, Earth would be a very different place. Sunlight also has a profound impact on human health. It stimulates the production of vitamin D in our skin. Vitamin D is essential for bone health and immune function. Sunlight also affects our circadian rhythms, regulating our sleep-wake cycles. Humans have long sought ways to harness the power of the sun. Solar energy technologies convert sunlight into electricity or heat. These technologies include solar panels, solar thermal collectors, and concentrated solar power plants. Solar energy is a renewable energy source. It is sustainable and environmentally friendly. As technology improves, solar energy is becoming increasingly cost-competitive with fossil fuels. It offers a promising solution to our growing energy needs. Sunlight is also used in other technological applications. It is used in fiber optic communication systems to transmit data. It is used in satellites to power instruments and communications. Sunlight is a versatile energy source with numerous applications. The sun is a powerful and awe-inspiring object. It is the source of life and energy for our planet. Its light and warmth sustain us. Its influence extends throughout the solar system. Understanding the sun is crucial for comprehending our place in the cosmos. As we continue to study the sun, we gain a deeper appreciation for its complexity and its role in our existence. We also learn more about the universe as a whole. The sun is a microcosm of the larger cosmos. Its processes and phenomena provide insights into the workings of stars and galaxies. The sun's enduring influence will continue to shape our world for billions of years to come. Its light will continue to nourish life on Earth. Its energy will continue to power our technologies. The sun is a constant in our ever-changing universe. It is a reminder of the interconnectedness of all things.